For generations, astronomers have gazed upward, captivated by a star that has long dominated our night sky. A blazing, crimson beacon resting in the shoulder of the Orion constellation. The celestial giant known as Betelgeuse has fascinated both scientists and stargazers alike. Massive, ancient, and inherently unstable, Betelgeuse is a red supergiant nearing the final chapter of its cosmic life. It has always stood as a symbol of impending transformation, an object poised at the very edge of collapse. Its brightness, variability, and sheer size made it one of the most studied stars in the galaxy. And yet, for all our technological progress, the timeline of its fate remained shrouded in uncertainty. Astronomers knew the end would eventually come, but they had no way of knowing exactly when or how. Spectacularly, that is, until now. The advent of the James Webb Space Telescope, JWST, the most advanced space observatory ever created, we have crossed a threshold in observational astronomy. What once lay beyond our grasp, we now watch unfold in real time. The death throes of a star captured, moment by moment. For the first time in human history, we are not merely theorizing about the end of a massive star. We are witnessing it with our own. And what we are seeing is nothing short of extraordinary. Betelgeuse, a star over 700 times the size of our Sun and nearly 20 times its mass, has begun its collapse. In 2019, astronomers around the world were stunned when the star dimmed dramatically over several months. The event ignited global speculation. Was this the beginning of the end? The countdown truly begun? Suspected it might be a surface disturbance or a temporary expulsion of this. But the truth, as we now know from Webb's data, was much more profound. Using its powerful infrared instruments, JWST peered through the dense clouds of gas and dust surrounding Betelgeuse to reveal a complex and chaotic scene. Magnetic fields are spiraling into disorder. Surface layers are convulsing, twisting, and bubbling with unimaginable energy. Giant plumes of plasma thousands of kilometers wide are being ejected into convective bubbles, some as large as Jupiter, erupt from the star's surface, breaking apart in spectacular displays of heat and light. This is not just the slow fade of an aging star. This is a transformation, a cosmic unraveling of matter and energy that signals the star's core can no longer support itself. Deep within, the balance between gravity and pressure has been, but the core is collapsing under its own weight, a process that, when complete, will unleash a supernova explosion of incredible magnitude, unlike the distant supernova we've seen in galaxies millions of light-years away. Betelgeuse is astonishingly close, just 642 light-years from Earth. In cosmic terms, it's practically next door. Proximity changes everything. For the first time, we are positioned to study the full anatomy of a supernova in real time. From the earliest tremors of collapse to the final explosion and its aftermath, and the implications are immense. A supernova is not merely the end of a star. It is also the birthplace of something new. These violent stellar deaths are responsible for creating nearly all the heavy elements in the universe: carbon, oxygen, calcium, iron, and beyond. Without them, Earth would not exist. Life would not exist. You and I would not exist. What Webb is capturing is not just a brilliant spectacle. It's a blueprint of creation. It's the universe showing us how it recycles itself, how it builds new stars, new planets, and potentially new life from the ashes of the old. In the depths of Webb's spectral data, astronomers have uncovered signs of previously unobservable phenomena. high-speed shock. Waves ripple outward from the core. Collapse traveling through the stars. Outer layers. Discrete bands of light. Encoded messages in energy reveal the emergence of rare elements like technium and yttrium created only during the final, explosive stages of stellar death. The fingerprints allow scientists to trace the path of matter across time and space, connecting the death of Betelgeuse to the formation of new worlds and ultimately the molecules in our very bodies. But this event is doing more than confirming what we thought we knew. It's challenging the boundaries of our understanding. JWST has also detected subtle distortions in the surrounding space, possible evidence of a gravitational ripple, a tremor in spacetime itself, if confirmed, would be the first time a visible supernova has been directly linked to gravitational wave data. It would be a historic moment, merging two fields, optical astronomy and gravitational wave physics, into one unified observation. We would not only be seeing the death of the star, we would be feeling it ripple through the very structure of the cosmos. And then comes the question that has haunted scientists for decades. Remains? Does Betelgeuse leave behind a neutron star, an incredibly dense object, the size of a city? Or will it collapse further into a black hole, a region so dense not even light can escape? Webb's early reading suggests something even stranger may be happening. The collapse appears asymmetrical. Material is not just being blasted outward. It's also falling back in. The magnetic field has broken down into chaotic fragments. Some astrophysicists now speculate that we may be seeing the formation of a new kind of stellar remnant, one never directly observed before. A possible intermediate object between a neutron star and a black hole. A long theorized but elusive entity. A new class of cosmic relic. As Betelgeuse transforms before our eyes, many people naturally wonder, are we in danger? The short answer is no. Betelgeuse is far enough from Earth that its radiation, shock, waves, and debris pose no immediate threat to life here. However, the explosion will send a tsunami of electromagnetic energy through space. Gamma rays, X-rays, cosmic rays, all of which could affect interstellar structures between us and the star. The next centuries, this energy may reshape dust clouds, alter the pathways of starlight, and even influence the conditions under which new stars and planets form. It may permanently change how we see the night sky. Betelgeuse will fade from Orion's shoulder. The brilliant red point we've known for millennia will be gone. In its place will be a swirling nebula rich with dust, gas, and elemental debris. But the loss is not the end. It is the beginning of something new. That is the paradox of stellar death. It is both a funeral and a birth. From this explosion, new solar systems will form. New planets may emerge. And perhaps in the distant future, new forms of life will arise. Life that may one day look up into its own sky and see the ghostly remnants of the star that once was Betelgeuse. The story is not just about astronomy. It is about us. The elements forged in Betelgeuse's core, carbon, nitrogen, oxygen, iron, are the same elements that make up every cell in your body. Heartbeat, every breath, every thought you've ever had is a product of stars that lived and died billions of years ago. To watch Betelgeuse die is to watch the cycle of life unfold on a cosmic fit. It's not just a scientific observation. It's a reminder of where we come from and a glimpse of where everything might be going. Thanks to the James Webb Space Telescope, we are witnessing one of the greatest transformations in the observable universe. We are not just spectators. We are participants in a shared cosmic history. And this event, this star, this death, this light may echo across time. longer than any civilization on Earth ever will. In the silence of space, Betelgeuse has begun its final act. But, in its collapse, it has left behind a message, a cosmic letter written in light, energy, and matter. The message that began long before Earth existed and will continue long after we are gone. The universe has more to say. The question is, are we ready to listen?